The third cosmic wanderer. The third identified interstellar body is now hurtling toward our solar system at an incredible speed of 130,000 miles per hour. At first glance, 3I Atlas appears to be nothing more than an oversized comet, yet its trajectory tells a far stranger story. It curves past Mars, Earth, Venus, and Jupiter in a rapid and exact sequence, a pattern with less than a 0.005% chance of occurring by accident. Its massive dimensions, unexplained acceleration, and astonishing four-planet flyby have scientists quietly asking if 3I Atlas could be a nuclear-powered reconnaissance probe designed to test how humanity might respond if this object was built. The implications would be beyond measure. Our first interstellar encounter and our global response could hinge on what we learn next. By July 2025, the evidence begins to accumulate. The object, cataloged as 3-2 Atlas, streaks across the solar system at 130,000 miles per hour, fast enough to cross the Atlantic Ocean in less than 2 minutes. Its diameter, nearly 20 kilometers, makes it the largest interstellar visitor ever recorded. For perspective, that is roughly the length of Manhattan, moving at a speed that surpasses any known comet or asteroid. Observation teams at the Rubin Observatory and TESS analyze early detections, logging every position with extreme accuracy. Using dozens of images, they reconstruct a hyperbolic orbit, a one-way path through the solar system unbound by the sun's gravity. Yet the calculations are not perfect. Small discrepancies in the data reveal deviations from the predicted gravitational curve, sparking debate among analysts. Could this be simple measurement noise or evidence of a force beyond gravity? Standard comet models anticipate minor non-gravitational acceleration caused by jets of vapor venting from heated ice, slightly pushing the core off course. However, in the case of 3I Atlas, the coma appears faint and oddly offset, with almost no indication of typical outgassing. Its photometric readings are equally puzzling. The brightness remains steady, showing no variations from rotation or jet bursts. For an object of such scale and velocity, any natural activity should leave visible patterns of change from thermal recoil or solar heating, yet the data displays an almost mechanical uniformity. Calculations of escape velocity confirm what the orbital model already implies. Unless it somehow slows, 3I Atlas will never be captured by the sun. Its hyperbolic excess speed, the motion it retains even after escaping the solar pole, ranks among the highest ever recorded for a natural object. The lack of a clear natural mechanism prompts the question, could some kind of engine be concealed beneath its coma? Astronomers push further, investigating every irregularity in the movement of this Manhattan-sized traveler. By August 2025, the revised orbit of 3I Atlas passes through the domains of Mars, Earth, Venus, and Jupiter, all within half a year. Each approach calculated within a fraction of an astronomical unit. It is not a simple solar pass, but a multi-planet journey, each flyby close enough for telescopes to obtain detailed spectra, yet distant enough to avoid capture or fragmentation. Simulations run by Rubin Observatory and independent research teams recreate this trajectory thousands of times. Even after adjusting for observational errors and potential gas jets, the same precise alignment persists. The path threads the orbital lanes of Mars and Earth, dips inside Venus orbit, then slingshots toward Jupiter. The geometry is extraordinarily rare. Galactic models based on random ejection and capture show that fewer than 1 in 10,000 interstellar objects would naturally fall into such a sequence. AVO Group publishes an even smaller estimate, less than 0.00005% probability of any random visitor repeating this four-planet pattern. The conclusion spreads rapidly through research papers and online discussions. Critics argue the odds may be distorted by survey bias, since telescopes mainly scan near the ecliptic plane, but even after adjustments, the rarity remains extreme. This intricate sequence inspires speculation. Could it represent a reconnaissance mission, a plan designed to observe multiple planets while minimizing risk? Each world offers a different view of the solar system, and the timing Mars, Earth, Venus, Jupiter suggests efficiency and caution. The pattern implies either intention or an order beyond what natural physics easily explains. The discussion expands when Harvard astrophysicist Avi Loeb, who previously proposed that Oumuamua might have been artificial, joins the debate. He argues that the motion of 3I Atlas is not a coincidence but a possible reconnaissance pattern. He calculates the odds of such a trajectory occurring randomly as less than 1 in 20,000. The claim spreads through research networks and public media, fueling theories that the object might be surveying our system rather than merely passing through.
Loeb compares it to the dark forest hypothesis, a concept suggesting that civilizations must hide to survive. If 3I Atlas were a probe, it might be examining the solar system from a safe distance, gathering data while avoiding capture or detection. Each pass is brief, calculated, and efficient, as if collecting information before anyone can react. Loeb's group notes similarities to Oumuamua's mysterious
2017 flyby, suggesting that if that was a scout, then 3I Atlas could be a follow-up mission arriving 8 years later. Skeptics argue that coincidence and observational bias could explain the pattern, yet the question remains unresolved. Could this be a neutral scientific survey or something more strategic? Astronomers weigh these possibilities carefully in a universe where silence might be the safest response. Meanwhile, planetary scientist Rachel Stevenson at JPL analyzes the spectrum of 3I Atlas and finds signs consistent with known comets. The coma, though faint and oddly directed, contains water, carbon dioxide, and organic compounds typical of icy bodies formed in interstellar space. Hubble imagery shows a diffuse forward-facing haze, but no metallic reflections or directional jets. Reflectivity readings correspond to bright icy grains, not engineered surfaces. For Stevenson and her peers, the simplest explanation remains the most plausible: a natural comet, though unusually large and peculiar. Spectroscopic analysis reveals an exceptionally high carbon dioxide to water ratio 8:1, implying an origin in a region far from stellar heat. Isotopic measurements align with those of Borisov and other comets previously seen. The coma's brightness fluctuates with solar distance rather than any internal rhythm, further supporting a natural origin. However, the challenge of reaching the object persists. Project Lyra engineers estimate that intercepting 3I Atlas would require a velocity change of about 60 km per second, far beyond today's rocket capabilities. Light sail technologies inspired by breakthrough Starshot could theoretically reach it, but only with microscopic payloads. After years of planning, ESA's Comet Interceptor, waiting at Lagrange Point 2, is ready for slower objects but lacks the thrust for such a pursuit. For now, observation must rely entirely on telescopes. Global policy experts review the Outer Space Treaty's protocols: no independent signals, no nuclear materials in orbit, all actions subject to international agreement. United Nations and SETI working groups debate whether humanity should attempt contact or maintain silence, weighing the dangers of exposure against the consequences of inaction. The guidelines remain consistent: observe, consult, prepare. As 3I Atlas continues its passage, its meaning becomes larger than astronomy. It represents a test of how humanity faces the unfamiliar. With its 20-kilometer width, 130,000 mph speed, and 4-planet passage, it ranks among the rarest travelers ever witnessed, despite measurable non-gravitational acceleration and trajectory almost impossible by chance. Spectroscopic results from the James Webb Space Telescope and ground observatories match known cometary behavior. Still, the mystery of its steady acceleration endures. 3I Atlas stands as a reminder challenging humanity to confront the unknown through science, readiness, and cooperation.